Natasha Stavros. Thank you so much for joining us here, but also in helping create this data puzzle. Dr. Stavros has a PhD in fire ecology and has spent much of the last 10 years with NASA and as a part of CU's Earth Lab Analytics, directing that, collecting and working with large data sets to develop data-driven solutions for a more resilient future. In working with her and speaking with her, she's more passionate about that than any other person I've worked with at CU. She's no longer at CU. She works as a mission lead for Ball Aerospace, but didn't lose this expertise in fire ecology overnight and still might be working in that space in many ways that I'm not aware of. So I invited her here today just to share a little bit about her work as a fire ecologist, her work analyzing these big data sets related to wildfire and how we can use those to inform decisions for the future. So thanks. Dr. Stavros, we'll turn it over to you.
Thanks, Jonathan. That's quite the welcome. And I apologize, everyone. I'm a little nasally. It's like allergy season here in Colorado for all of us. Yeah, I've been working on fire ecology for long time, more than 15 years. So let's just put it that way. And a lot of people are kind of like wondering what is fire ecology. And if you break down and think about like what the term ecology means, it looks at an entire system. So it's how fire plays a role in the system, in the environmental system. But what I've been working on doing is really kind of expanding that beyond sort of the traditional views. So traditional views have focused on fire as what we would say an extrinsic phenomenon, right? It's like a thing that happens to us. It's a thing that happens in nature that we experience. But the thing about fire is that we actually affect fire, right? So it's not extrinsic to us, not a hurricane that's happening to us. We are sometimes prescribing fire on the landscape, and actually over 96% of the fires that burn homes and near homes in the United States are actually started by people, right? So that's an important part. Like, we are a part of this system. And so if you think about fire ecology as just like in the environment is inclusive of not just the natural world, but the human and natural world. And so that's a lot of like what I focus on, and it's very complicated environment. And I'm deeply passionate about not just how complicated it is, but how can we simplify it so that we can actually tackle it. And what I mean by that is that, like, and the most important thing, and I hope Jonathan shared this with you, is that we don't make fire a villain, because there's like good fire that can help, right? And so we need to not sort of villainize fire. We need to understand that some fires can be destructive, and some fire can help reduce the chance of extremely destructive fire. And so it's not just a binary good or bad, it's a gradient of where fire fits. And so that's kind of been a key part of my messaging. So with that, I'll just stop. I saw a really great question in the chat from Linda, which I'm happy to talk about if Linda wants to share her thinking.
Yeah, sorry. I know I just finished up discussing the picture right before we came back from break. However, I just wanted to verify and double check. So whenever we're drawing the past, present, future model, yes, that one. My train of thought would be, if we're having more mega fires, we wouldn't draw in as many large trees. So I'm not saying that you drew in more large trees. I'm just clarifying a thought. So for the future, wouldn't we see more smaller trees who never had the ability to get to become large trees as more mega fires are breaking out?
That is such an excellent question. So
kind of like overfishing, so the fish never get bigger.
Yeah, no, that's a really great question. So this is another one of those things where it's not like a direct answer. And the main reason for that has to do with the fact that it depends on how frequently the megafires are happening in the exact same location. And the thing in this particular data puzzle is that we focus on fire size. But fires are actually so much more than just size, right? Like there's a lot of women on this phone call, right? Like, so it's not all just about size. Sometimes it's about like severity. So that's like, how severe is it? And you are totally on the money there, that when you have something that is high severity, what that means is that it burns into the crown of the trees, and that can actually kill the trees. And so sometimes when we have megafires, we actually kill what are called legacy trees, or the big trees that are still there. But if we have more fires that aren't megafires, like let's say we had more prescribed fire, or let's say we just had more frequency of megafires, there wouldn't be enough fuel to get the fire into the canopy in the first place. And so what might end up happening is you have those legacy trees that remain and the new trees that come in. The other thing that can happen that you're kind of hinting at is that it's called type conversion, and it's actually happening all across the Southwest. So Arizona is experiencing it a lot. And that's where if you have a lot of rapid, megafire events, not only are you killing the legacy trees that are mature enough to create the cone, the ceratinous cones, and et cetera, for regeneration for the next generation of seedlings, but you're also burning through any seed bank that is in the soil. And so that's when it can make it more of a prime environment for actually typically invasive species like sheetgrass and other flashy grasses that can burn faster and more frequently, which means that no seedling ever stands a chance before the next fire happens. And so you can convert the landscape from what was once a forest to a grassland. And this is actually a fundamental limitation that we have in these models, is that these models were, one, really hard to develop, but what you see in this data puzzle, because you've heard of like normal distributions, right? Like most of your students should fall in the C, and then some in the B, and then very few in the A.
Yes,
right?
but
Like
their parents don't think so.
I know. And my husband's a teacher, so I totally get you, right? But right, like, so that normal distribution, that's how most statistical models are created, is assuming this normal distribution. But anything that happens over here on the tail, like those A students or the exceptional cases like megafires in the past, they're very hard to create confidence around. And so that's the challenge with the models that you see now. And then you add to it the fact that not only were they developed on a limited sample size, but now what happens if the environment actually changes the way that you're talking about? That's like a real uncertainty. We don't know, because what was once forest and the model that might work in a forest now no longer works because it's actually a grassland.
I appreciate it. I just like to forethink questions that I'll get, because I've always taught honors 8th grade and then AP environmental science, and so I can anticipate the types of questions they would ask just by looking at what I did and what I didn't do.
Yeah, and those are all really great questions, and I think that that's like a great lesson in uncertainty, right? Like, why do we write down what is uncertainty? What does it mean? What are the known knowns, and what are the known unknowns, and what are the unknown unknowns? Like, what could possibly be an unknown? And I actually have a TEDx talk on that whole topic. But yes, like, that's a great topic for your students, and it's awesome that they're even thinking like that.
And Linda, those are great questions, comments, and it makes me wonder, Natasha, in looking at this is the answer key that I've created, and we have a past, present, future. The data set for this data puzzle only looks at the past and present and doesn't look at the future. Given that we know there are lots of uncertainties, is it fair? Do you think that this should be included in the the final a task for students, or do you think we should remove this block given that there is such uncertainty and just have them focus on the past and present?
I don't know. I mean, I guess that's a question for all of you as teachers. I don't know how to teach very well. And I know that there's a lot of nuance in it, but I could see some value in just saying, what do you think the future is? And do you think this is the only scenario? Could you imagine multiple scenarios, right? Like you're kind of probing them at the uncertainty question without getting into the nuances of what is statistical uncertainty. I could see value in that.
I think that's an excellent extension activity to add on to having a future, especially with the previous figure 3 data that you had up there to show what future projected temperature change. Yeah, that one. Drynesses and temperatures. They could use that caption right there and place their megafires and their foliage and their vegetation and temperatures, and place all your keys into a future graph that map that looks like that, and then explain why that would be a great thing for the above and beyond, or to offer bonus point type of activity. And it does make them think and apply the information. It's one of the things I was saying in my group, that we're too much of a memorize and regurgitate, and I'm not a memorize and regurgitate teacher whatsoever, that we're losing the ability to think and to process. I like having the future. I just wanted to make sure that I thoroughly understood whether or not to include larger trees. I do see exactly what you're saying, especially based on the video we had seen before. But I just want to have my bases covered before kids ask me questions and I look like a deer in the headlights going, well, that's a great question. Why don't you look into that and let me know tomorrow? That sort of outcome.
Yeah, one way that you could do that, John, and just like talking with your teachers right now, is if you pull up that chart, one way to frame it to help your students like make that sort of connective tissue is if you were to say, what happens if, and I don't know where all of you are located, but pick your location. I'm going to pick Southern California because that's where I grew up. What happens if California ends up looking more like Arizona? Like what if, because of climate change, or what happens if, we know that with climate change, ecosystems are moving north. So what happens if what's happening in Utah sort of stretches up into Idaho? What if we have so many megafires that the forests in Idaho start to look more like grasslands and you have desert creep? So that might be a way to frame it, to have that conversation.
Thanks, Natasha. Shelly had a question. I think, you kind of answered it, about the size of trees in this final model. She was interested if that would be true for trees with serotinous cones that are fire adapted, and you kind of
answered that question essentially.
Answered that question.
So I'm good.
Yeah. Okay, great. Just wanted to make sure you felt like that was the answer. A question from Dana. She's in northern Colorado, and there's a large area that was recently clear cut to prevent fires. She's wondering if controlled burns would have been better, and what are the pros and cons of both?
Oh gosh, you guys are all like, can you all go to Congress? And these are great questions.
I'm here. I just didn't know where the hand raise was, but yeah.
Okay, awesome. Yeah, that's a great question. So there are pros and cons to both. And actually there's a lot of research that goes back and forth, and it all kind of depends on the local area, and sort of what's happened there historically. So one challenge with going to a place where we've had fire suppression for 100 years and doing a prescribed burn is that you actually have so much fuel buildup that there's no way for us to really do it in a safe way, both for people and for the environment. Because as I was mentioning, when you have a high severity fire and it burns into the crown, because you have a lot of fuel growth and ladder fuels, because you haven't let fire be there for a long time, you could actually kill the ecosystem, especially if it were to happen multiple times. And so in those cases, you might want to go in and do something where you clean it up first and remove some of those ladder fuels before you do a prescribed burn. So that can be really like a good thing. The other thing is that it depends on who owns the land and for what purpose they're managing for. So for example, there's a big difference between the Park Service and the Forest Service. The Park Service, their mandate is conservation. The Forest Service, their mandate is managing natural resources, of which timber is one of them. And it is an important commodity for our economy and for society. And so there are times where you have to weigh, do we do a timber harvest? Do we go in and mechanically thin? And then what they would do with that mechanical thinning is they would create these like brush piles and then burn just the brush piles. And then once it's been cleared, they can do a cleaner prescribed burn just in the lower canopy. So there's lots of different ways you can do it. And I will say that there's another sort of element to this, which is policy. So there's 3 policies that affect whether or not we can have fire in the United States, like prescribed fire in the United States. And I think I've been saying prescribed fire. Does everybody know what prescribed fire, what I mean by prescribed fire? Okay. So I'll just say prescribed fire is like when we humans say this area needs fire and we're going to do this area on this day, etc. And then we go with blow torches and we start a fire and we burn through it. And it's intentional. But there's 3 things that can affect our ability to be able to do that. There's 3 policies that affect it. The first is fuel hazard reduction. Obviously that would be like, okay, well, of course we want that. But in combination with fuel hazard reduction are these things that every time you go into federal lands, you see Smokey the Bear with a little sign that says the fire danger. That's all determined based on something called the National Fire Danger Rating System, NFDRS. And that is like where they use weather and they say, hey, if you had a fire today, it would be scary, right? Or if you had a fire today, it wouldn't be so bad. There's been a lot of rain, a lot of snow, whatever. And so that's sort of the fuel hazard and the fire danger. That's one policy. The other thing that affects our ability to burn is the Endangered Species Act. There are a lot of species like the northern spotted owl that require what's called old growth forests for their habitat. And so those, because they're endangered species, their habitat is protected. And so if we prescribe a fire and we want to prescribe a fire all the way around an old growth forest, that's very hard to get approved, because what's to say that that fire wouldn't affect that habitat? So that's one thing. And then the third thing is called NAAQS, National Ambient Air Quality Standard. And that's by the EPA. And so this is where it gets tricky, because wildfires, when they produce smoke, wildfires will naturally produce smoke. When people intentionally prescribe a burn, it also produces smoke. But here's the catch. When we intentionally prescribe a fire, those emissions, both in the public's eye and internationally, are counted as anthropogenic or man-made emissions. Even if we were to say, if we did nothing and it were to burn in a wildfire, it would be so much worse. In a wildfire, it's not counted, right? But when we intentionally do it, it's all of a sudden counted. And so there's the public perception. So anybody who's in Florida, you probably have heard a lot about hazardous smoke, or anywhere in the Southeast, you hear about hazardous smoke. Because they do a lot of prescribed burning in the Southeast, it produces a lot of like wet, it's like kind of wet. And so it produces a lot of excess smoke that can blow in front of cars and cause car accidents. It's been on the news many times. And so there's the public perception of the smoke that you create. And especially if like people are coughing, it causes asthma. Well, why did you prescribe a fire that's now affecting me? it's very hard to explain to the public, well, if I didn't and it were to just happen naturally, you would still have this problem and it would actually be worse. Because when we can prescribe a fire, we get to pick the day that we do it, which means we actually can get completely different cocktail of emissions than if it were to just burn naturally in the middle of summer when you have all this extra sunlight, which causes different chemical reactions. So that's a very hard, there's the public perception and then the policy for reporting on greenhouse gases and air quality that is also an element that we have to navigate for prescribed fire.
Thanks, Natasha. I'm with Shelley on this. I had not thought about those 3 pieces of legislation, so thanks for sharing that. Shelley, do you want to chime in and ask your question?
Yeah, if it didn't just leave my brain. I'll type it in the chat if I can remember it.
Okay, great, thanks. There's another question in the chat about letting lightning create natural fires and creating buffers around housing and civilizations. Thinking about that as an approach.
Yeah, so that's a great question. Historically, we had, so the history of fire, you can read books on this. There's a book called The Big Burn. And so what happened, actually, when I tell the history, there is like a famous fire historian, Stephen Pine, but, and I'm not a historian, but I have been interested in the fire because I don't believe that where we are today wouldn't be so if we didn't understand the history. And so if you actually look at the, hold on, I'm going to pull up a great slide to be able to show this to you. But if you look at the periodicity of fire in the United States, we've actually seen natural variation of more and less fire. And it very much aligns with the fire that we have, with our fire policies. But in 1910, there was the Big Burn, and that was in, I want to say Yellowstone area. And it burned millions of acres and people died. And the United States developed what was called the fire exclusion policy. And that was all fire is bad. And that they developed something called the 10 a.m. rule. All fires must be out by 10 a.m. If they're not out by 10 a.m., they're out by 10 a.m. the next day, right? So it's like all resources put to exclude fire, independent of ignition source. And then there was something that developed in around like the 50s. White America was like, oh, well, we've invested all this in our scientific community, and our scientists are telling us that these ecosystems actually need fire. So maybe it's not a good idea for us to exclude fire. And the reason why I say white America is because it's really important to note that there are like a lot of racial elements to the way that fire has been handled all across the world, but I can speak more about it in the United States. The indigenous people and First Nations of this country have used fire for millennia to, as they call it cultural burning. So cultural burning is a lot like prescribed fire, but it's used not just to reduce fire hazard, it's used for cultural purposes, to sometimes inspire certain growth of wildflowers or different things that are of value for cultural assets. And so, cultural values. And so, that's why I mentioned that, like, if you were to talk to any First Nations, they would say, well, this is not our history. Fire's always been important to us. And it's, white America that colonized us that implemented this exclusion policy. And we could have told you for millennia that this was of value to us. But white America in the 50s started realizing how important and essential fire was for ecosystems, and the scientists started advocating. And then in 1988 there was the Yellowstone fire. That was also another really big fire, and everything just burned, and you can still hear about it today. And that was a good turning point for okay, we're going to now switch from fire exclusion to fire suppression. And so what that meant was in places that were really remote, where there were no human or anthropogenic resources, like remote parts of Alaska or other parts of the Western United States where we just don't really have dense populations or any national assets, we let the fire burn. And so that started in about the 80s, but then this was all again complicated in the 90s when the National Ambient Air Quality Standard and the Endangered Species Act came into play. And so there is a big push to let certain fires burn, but there's also this balance with policy and public perception that has to happen.
Thanks, Natasha. Yeah.
Yeah.
I wasn't sure if you were still looking.
I am. I was just got
Yeah.
a little distracted.
Yeah,
talking.
understandably.
I'll pull it up before, and you guys can just take a screenshot of the history.
Great.
I just need to like look for it as the next questions come
Yeah,
in.
yeah. If it's okay with you, well, I mean, I am recording. This is recording right now. If it's okay with you to share this with those that are in here, would be a really valuable resource to us as we try to communicate this information to students. So thank you for that. Robert has a question about pinyon juniper encroachment. It's a northwestern Colorado topic, he's saying, and he's wondering if you foresee major action from the Forest Service with regards to this pinyon juniper encroachment. He says fire exclusions played a role in this, and we're seeing a loss of sagebrush and more juniper, and this is impacting habitat for sage grouse.
Yeah, so I'm sorry, I missed the question part of that.
Do you see any major action from Forest Service regarding pinyon juniper encroachment? Oh,
yeah, there are definitely a lot of people who are concerned about, like I told you, the ecology term is type conversions. So there's the type conversion where we don't have fire at all, and what ends up happening is juniper encroachment, right? Like, and prairie encroachment, all of these like natural prairie lands that are great little safe havens for wildlife up in the mountains, they start to go away and it just becomes crowded with trees. The other type of type conversion you can have is frequent megafires that then all of a sudden reduce the seed bank and make it impossible for what was there to exist. And it's not just the frequent fire rate, like climate changes, right? So what's more adapted for the current environment just has a better advantage. And that's where you can get the switch to grasslands. So both of those kind of type conversions can happen. And the Forest Service is very aware of this. And so are scientists. There are some people who dedicate their entire lives to researching this. The challenge goes back to how do we manage? And if it comes back to we need to have more prescribed fire, even up at high latitudes or high elevation, like mountain ecosystems where you see that juniper encroachment, like that still, you might not want to burn a prescribed fire like every 5 years, like you would in Southern California, but even just doing one prescribed fire, right? Like every 50 years could make a huge difference. But even just getting the permission to do that prescribed fire, one, it's getting the permission. Two, it's having the money and resources. So the more megafires we have, the less money we have to put towards proactive treatment because we are in a reactive state. And that's the same with our energy reserves, right? The more we're like on alert and fight or flight mode, the less energy we have to like, be mindful. And that's the same sort of thing that's happening. So one, we have policy that we're up against. We don't have the money is being reallocated. So there's one pot of money that goes to the Forest Service, and a lot of it goes towards reactive management, and the cost of reactive management increasing takes more away from proactive management. And then the final thing is, like I said, the public perception, getting the sign off from the community. And unfortunately, there are some conservation groups, and I'm not trying to rag on conservation groups, but they have very focused ideas about what conservation means that aren't necessarily always holistic. So it might be like we can't allow fire because of this one little species. And it's like, well, maybe that one species would do better if the whole system was happy. So there's that. And so sometimes it's really hard when the Forest Service is kind of like always trying to encourage more prescribed fire, and they just can't, right? Like there's just those barriers.
Great, thanks, Natasha. Does anybody else have any questions for Natasha? And if you can't find that figure, then I'm happy to upload it and link to it when you do. So it's a lot to be on the spot right now. So no pressure. I can upload it.
No, I found it. I found
got
it.
it?
I just had to think in my organizational structure that I have for all of my stuff. So hold on, it's loading right now. But.
Great. Well, thank you so much for being here. Unfortunately, Shelley, it doesn't look like your questions come to top of mind. So, but you can reach out to me with your question and find somebody at CU or Natasha that can help answer that question.
You know what? I'm gonna have to, for some reason, when I load my PowerPoint in Google, it's not showing the full figure. It's only showing part of it.
Yeah.
I'll screenshot it and send it to you, John, and you can send it around to people about the history of the United States.
Great. Thank you so much. It looks like that's it.
Awesome. Well, thank you all for teaching this subject to your students.
Thanks for being here, and thanks for your help in creating this resource. I also want to point everyone, I think, in the scavenger hunt, but at the end of the teacher guide, there are a number of resources that Natasha has produced, videos, articles, podcasts that really focus on resilience and that sort of space. So please look at those resources as well.